Hi everyone. Our lesson for today is nonlinear differential equations. Nonlinear differential equations are also called Bernoulli's differential equations. These equations are of the form dy over dx plus p times y equals q times y raised to n, where p and q are functions of x. To solve nonlinear differential equation, it must be reduced to linear differential equation and apply that method in solving the given equation. Let us study how to reduce nonlinear differential equation. This is the form dy over dx plus py equals q times y raised to n, and this is to be reduced into linear differential equation. Remember our form dy over dx plus py equals q. Given this nonlinear differential equation, and we consider this to be equation 1. The step 1 here is to divide both sides by y raised to n. So the new equation becomes y raised to negative n times dy over dx plus p times y raised to 1 minus n equals q. And we consider this to be equation 2. Now take note of this variable y raised to 1 minus n, because in the second step we're going to let v equals this variable, that y raised to 1 minus n. And then we're going to take derivative of this equation with respect to x. So we have now this dv over dx equals the quantity 1 minus n times y raised to negative n times dy over dx. Step 3 is to substitute corresponding values to equation 2. And the new equation becomes dv over dx plus p sub 1 times v equals q sub 1, where p sub 1 and q sub 1 are functions of x. Example 1. Find the general solution of the differential equation dy over dx plus 1 over x times y equals 3y cubed. Let us convert first into linear differential equation. First thing to do is to divide this equation by this y cubed. And the new equation becomes y raised to negative 3 times dy over dx plus 1 over x times y raised to negative 2 equals 3. This is now our equation 2. Next step is to look for this y raised to negative 2. We're going to set this into v equals that value, the y raised to negative 2. Then we will take the derivative of this new equation with respect to x. So we write dv over dx equals negative 2 times y raised to negative 3 times dy over dx. Let us consider the first term of this equation 2, this y raised to negative 3 times dy over dx. Let us rearrange this derivative here to conform with the first term. So we have now this y raised to negative 3 times dy over dx equals negative 1/2 of dv over dx. Next step is to substitute corresponding values to equation 2. So equation 2 now becomes negative 1/2 times dv over dx plus 1 over x times v equals 3. We want to show that this equation conforms with our linear differential equation. Let us multiply this by negative 2. So we will have this new linear differential equation as dv over dx minus 2 over x times v equals negative 6. Let us solve the linear differential equation. We can collect the values of p and q. And these are p equals negative 2 over x and the q is the negative 6. Finding for integrating factor, that is the if, we have this formula e raised to the integral of p dx. Let us substitute the value of p, and the value is the negative 2 over x. Then we integrate. It will result to the negative 2 ln of x. We can rewrite this expression into e raised to ln of x raised to negative 2. We know that this e and ln will cancel each other, and this would be simplified into x raised to negative 2. And when we rationalize, we can rewrite this into 1 over x squared. This is our integrating factor. Going now to the general solution, with respect to the v, this is now the equation. Then let us substitute corresponding values. The v is this y raised to negative 2. The if is this 1 over x squared equals the integral of q, we use this negative 6 value, times the if, again we write 1 over x squared times dx plus c. On the left side, we'll just combine the two, so we have this 1 over x squared times y squared equals, we integrate now in here. So we write negative 6 times x raised to negative 1 over negative 1. We simplify the expression here into 6 over x. Then we want to let the variable y alone on the left side. Let us multiply this equation by x squared. So we'll have this 1 over y squared equals 6x plus c x squared. This is now the final answer. Example 2. Find the general solution of the differential equation dy over dx plus 1 equals e raised to x minus y. First thing to do here is to rewrite the equation into dy over dx plus 1 equals e raised to x multiplied by e raised to negative y. Next is, we divide this equation by e raised to negative y. So the new equation becomes e raised to y times dy over dx plus e raised to y equals e raised to x. And this will be our equation 2. Next is, take note of this e raised to y, because we're going to let v equals this value e raised to y. When we take derivative with respect to x, we have this dv over dx equals e raised to y times dy over dx. Next is, we substitute corresponding values to equation 2. The equation 2 now becomes dv over dx plus v equals e raised to x. Then let us solve the linear differential equation. We can collect the values of p and q as follows. The p is equal to 1, that is the coefficient of v. And the q is equal to this value e raised to x. Let us solve for the integrating factor, the if. The formula is e raised to the integral of p dx. Our value of p is 1, so we substitute it here. When we simplify the integral, it becomes x. So we have the IF to be e raised to x. Then we get the general solution formula here. Let us substitute corresponding values. The value of v is this e raised to y. We write it here. The IF is this e raised to x equals the integral of the q, the value is e raised to x, times the IF, again, we write the e raised to x, times dx, then plus c. On the left side, we just combine this e raised to y times e raised to x into e raised to x plus y. And the integral of this e raised to x times e raised to x dx is simply e raised to 2x all over 2. Then we write the plus c. This is the final answer. Example 3. Find the general solution of the differential equation dy over dx plus 2y over x equals x raised to 6 times y cubed. Let us convert into linear differential equation. Let us divide this equation by y cubed. So we have this y raised to negative 3 times dy over dx plus 2 over x times y raised to negative 2 equals, the right side becomes x raised to 6. We consider this now to be equation 2. Then look at this y raised to negative 2. We're going to let this y equals negative 2 to be that value v. Let us take derivative of this equation with respect to x. So we have dv over dx equals negative 2 times y raised to negative 3 times dy over dx. Considering the first term of this equation, let us rearrange our equation here. So we have this y raised to negative 3 times dy over dx equals negative 1/2 times dv over dx. Next, let us substitute the corresponding values to equation 2. So the equation 2 here becomes negative 1/2 times dv over dx plus 2 over x times v equals x raised to 6. Let us put this into standard form by multiplying this by negative 2. So our equation becomes dv over dx minus 4 over x times v equals negative 2 times x raised to 6. It is now converted into linear differential equation. Let us solve this equation. We can collect the values of p and q respectively. The p is equal to negative 4 over x, while the q equals negative 2 x raised to 6. Then we compute for the integrating factor. The formula is e raised to the integral of p dx. The value of p is negative 4 over x, so we substitute it here. When we evaluate the integral, we have now this negative 4 times ln of x. We can rewrite our exponent into ln of x raised to negative 4. We know that this e over that ln value will cancel each other. So we simplify this into x raised to negative 4, which is simplified further into 1 over x raised to 4. This is our IF. Then the general solution formula. Let us substitute the corresponding values. For the value of v, that is equal to y raised to negative 2. So we copy it here. Times the IF, that is the 1 over x raised to 4, equals the integral of q, our q is the negative 2 x raised to 6, times the IF, which you write again as 1 over x raised to 4, times dx plus c. For the left side, we just put them together, while in the integrand here, we can simplify that x raised to 6, and there is the denominator here of x raised to 4. So we simplify it as negative 2x squared dx. So the integral of this will be negative 2 times x cubed over 3. At this point, we want to make our y variable alone on the left side. We can multiply this equation by x raised to 4. So the simplified equation will be y raised to negative 2 equals the negative of 2x raised to 7 all over 3 plus cx raised to 4. This is now the final answer. I hope you learned something from this video. See you again next time.